numbers 2 and 3 together, because they're the more difficult ones on the page, okay? So we'll do those together. Looking at number 2, Mr. Franklin puts 300 pounds of yard waste in the back of his pickup truck to take it out to the composting facility. When the pickup was loaded with the yard waste, the rear bumper was 13¼ inches from the ground. On the way home, he stops at the concrete industry to buy some gravel. With 1,200 pounds of gravel in the back, his rear bumper was 11 inches from the ground. You're going to be asked to write an equation for how far the bumper of the pickup is off the ground. So I'm not actually going to go in order through these, because the first thing that we need to talk about is our variables. What are we comparing here? The bumper height, and what else? Oh, the weight. Now, which one of those is independent? The weight. The height of the bumper depends on the weight in the truck. So when we define our variables, that independent, or X, is the weight in pounds, and our Y is what depends on the X, so our Y is the height of the bumper. In pounds. Nope. Thank you. Inches. Height pounds. That would be silly. So now that I've figured that out, we need to go back into the problem and pull the points out. Was the slope given to me? No. They just said he loaded compost. This is what happened. He loaded gravel. So he loaded his truck twice, which means what do we have? 2 points. The first time he put 300 pounds, and what was the height? 13¼ or 13.25. So our first ordered pair is 300, 13.25. Here's a scenario where we can turn things into decimals. What about your second point? 1,200. Good. 1,200 pounds would be 11 inches off the ground. Good. You?
Add the 1,200 and 300.
The more you put in the truck, right? Right? If you've ever been on like a road trip and you put all the stuff in the car and then it just like, right, gets a little bit closer, because the more weight you add, the closer you are to the ground. Okay, so use the point slope formula to find the height of the bumper that is off the ground and transform it into slope intercept form. What am I missing from this run? That would be the y-intercept, right? So the starting height is our y-intercept, but we're not going to figure that out until we transform our point slope into slope intercept form. Good point, though. What am I missing? Slope. 300, 13.25, 1,200, 11. How many slope?
Mine's negative.
0. Oh no. It's negative too, isn't it? No. Change in y minus 2.25 over 900. Negative 2.25 over 900. Put in your calculator. negative 0.0025. Let's use the decimal. Because think about the scenario itself. What that's saying is for every pound that he puts in, it gets 0.0025 inches closer to the ground. Okay, so my point slope equation, y, doesn't matter which point I use. Which one would probably be easier? 1211, we got whole numbers. So y minus 11 equals
Negative
0.0025 times
x
minus 1200. Okay, I need to convert it into slope-intercept form. So you guys distribute and turn that into slope-intercept form for me. Y equals negative 0.0025x what? Plus 14. Everybody get 14?
I got minus 4.
Did you distribute? Okay, hold up. I'm out. Negative 0.0025 times 12, negative 1200. What did that give you? Negative 3 plus 11. No, it should have been positive.
Yeah,
It's positive.
No, a negative time, no, a
No, a
negative.
negative times a negative is positive.
It's
So
a-
this, no, this is 3. If you add 11 to the other side, that is 14. Okay, use your equation to find out how far off the ground the bumper would be. So wait, what is the y-intercept? 14. So the truck starts 14 inches off the ground. Okay, use your equation. How far the truck would be off the ground if you put in a 100-pound ladder rack? So where would I put 100? X. What'd you get? 13.75. Good. All right, number 3. Mrs. Pritchard enters her classroom at 7 a.m. and finds the temperature to be 86 degrees. She immediately turns on the air conditioner. By noon, the temperature was down to 76 degrees. The temperature went down at even rate while the air conditioning was running. Write an equation to find the temperature in Mrs. Pritchard's room. What are we comparing here?
To time.
Time and temperature. What's independent? Time. Leave a little space after time because we're going to expand on that a little bit. There's more than just time here. Time and temperature. What would your points be? Okay, so question. Think about that, 786 and 1276. Would I be able to find the temperature at 5 p.m. by plugging 5 into whatever equation I'm fine?
No,
Because I went from 12 to 1, right? As time goes on, we go 7, 8, 9, 10, 11, 12, 1. I can't plug in 1 after 12.
13.
I would plug in 13, so I could either use military time, or realistically, when she walks into her room, what would my y-intercept be?
Well, it would be zero, because it's the starting point.
So the y intercept, what would the y intercept be? 86 degrees. She walked in at 86 degrees. What else do you know about a y-intercept?
It's the B.
It starts at 0, right? So instead of time, what could I do to measure what's happening and starting at 0 instead of 7? If I use 0 for 7 a.m., what do you think I'm going to use for noon?
5.
5. Why?
Because it's 5 hours, you gain 5 hours.
You gain 5 hours. Love it. So 5 is, oops, I put the wrong degrees here. This was 86, and this was 76. And you gained 5 hours, so we're not just going to put time, we're going to put time since 7 a.m. Because that's when she turned on the AC.
You have to do that.
Yeah. That's the y-intercept. Because think about it, right? Like, you're not measuring anything that was before 7 a.m. You're thinking, when did she turn on the AC unit? Just because it was 7 a.m., you think a little bit more about how time works because of that whole 1 p.m., 2 p.m., 3 p.m. thing. Okay,
Well, we're missing slope.
we are missing slope. Can we find it though?
Yes.
Find it.
-2.
-2. So -2 is my slope. What does that represent in this scenario?
The temperature decrease.
Temperature goes down. How many degrees?
2 degrees.
2 degrees each hour. I probably didn't have to write all of that, but yeah. So it says use point slope form to find an equation and transform it into slope intercept form. But I want to ask you a question. Do I need to start in point slope to get to slope intercept in this scenario? Oh, why? Because I have my y-intercept, y'all. I have my y-intercept. So we're going to skip this step because we realistically don't need it right now. So let's go straight into slope intercept form. Y equals -2x plus 86. So about what was the temperature in the room at 10 a.m.? What do I need to figure out here? 10 a.m. So what would x be at 10 a.m.? 3, because that's 3 hours after she turned on the air conditioning. So where is that going to go? Replace the x, right? So y equals -2 times 3 plus 86. So -6 plus 86, 80 degrees. All right. Y'all are going to do 1 and 4 first. So, hold on just a second. I know you're trying. 1 and 4 first, and my goal is what we did in first period because it took so long to go through those. We are definitely checking 1 and 4 before you leave. 5 and 6, if you finish 1 and 4 and we haven't checked it, you're going on to 5 and 6. We're checking those Monday. So if you finish them all while you're here, great. If you don't get through them, you have to finish them over the weekend. Okay?